During this lesson, I want to talk about furnace types, construction, and efficiencies. The design of a furnace is based on the type of fuel used, space available, and heat transfer media. The heat transfer medium may be air, water, or steam. There's three types of furnace construction. We have upflow, we have downflow, and we have horizontal. The upflow furnace is the most common type due to building construction. It takes air and forces it up through the bottom of the furnace. An induced blower motor increases the system's efficiency. It forces air through the heat exchanger, which is at the top of the furnace, and into the ductwork. The downflow furnace is also referred to as counterflow. It forces the return air through the top of the furnace downward through the heat exchanger. The horizontal furnace requires the air to flow horizontally through the heat exchanger. Return air is pulled through the end opposite of the heat exchanger. All furnace types require the installation of cold air return to supply the furnace with air to be reheated or recooled. Most of the furnaces are of steel construction. The blower compartment is lined with insulation to reduce heat loss or gain, and most importantly, decrease the noise of the blower. There's usually a section provided for the installation of an air filter. A safety interlock switch is often provided inside the blower access door. When the door panel is opened or removed, the switch de-energizes the electrical power to all components. Newer furnaces have very high efficiency ratings. These furnaces use less fuel and produce more heat. The management of efficiency for furnaces is the annual fuel utilization efficiency rating. It compares the yearly or annual energy rating output to the annually energy rating input. The higher the AFUE rating, the more efficient and cost-effective the furnace. The federal government's minimum efficiency standard currently is 78% AFUE. Higher efficiency furnaces can have ratings above 84% AFUE. Approximately yearly operating costs are shown in this chart for various furnace efficiencies. So if we have a 70% efficient furnace, we might be paying, depending on fuel usage, between $340 and $845 per year. High efficiency furnaces may contain improvements in flue pipe routings, high heat transfer exchangers. Secondary heat exchangers that extract as much heat as possible from the system also may be present. The temperature at which the flue gas is emitted to the atmosphere is greatly reduced. Reduction in the flue gas temperatures result in condensation of water vapor in the flues. This is an example of a high efficiency furnace. PVC flue piping is used for flue exhaust and air intake. Mid-efficiency furnaces have an AFUE rating of approximately 79 to 83%. It also uses a high heat transfer heat exchanger with induced draft motors. They usually have a flue gas outlet of only 3 inches due to the heat exchanger design and a decrease in combustion products. They may use Class B chimney or approved flex chimney liners. You always want to check local code before you install a chimney. It might be a low profile installed horizontally or vertically. All furnace installations must conform to the recommendations of the manufacturer as well as local codes. This is an example of a mid-efficiency furnace. Notice you have a draft inducer motor, you have a restricted heat exchanger that will restrict the flow of flue gases out and keep them in the furnace longer, allowing them to absorb more heat into the air being blown across it. Mid-efficiency furnaces vary from high-efficiency furnaces due to the lack of the secondary heat exchanger. The chimney for the exhaust gas also varies. Hot flue gases are sent directly through the chimney and much heat energy is lost. The heating section of a mid-efficiency furnace consists of burners, a steel heat exchanger, and a venting system. With the mid-efficiency furnace, the thermostat calls for heat, the gas valve is opened, gas flows to the burners, an electric spark ignites the gas, the flame warms the heat exchanger, that in turn warms the air. Hot gases for combustion collect at the top of the heat exchanger and then are routed to the vent. The high-efficiency condensing furnaces vary. They're the most popular furnaces on the market today. They have an AFUE rating of 84 to 95% efficiency. The components include a flue pipe, heat exchanger, and a secondary heat exchanger. If you take a look at the picture on the right, you see the primary heat exchanger, or the larger tubes near the top, and then the secondary heat exchanger is at the bottom. What happens is the flue gas goes through the primary heat exchanger first, directly from the burners, and then cools down and then gets routed into the secondary heat exchanger at the bottom and further cools. This is where the condensation happens. The flue gas cools below the point where the water vapor is in a vapor form, and it changes to a liquid form. Outside air enters through the PVC pipe running through a wall or the roof. A traditional chimney is not needed. Exhaust through a PVC pipe, also running through the wall or roof. What happens in this furnace? The gas flame heats the primary heat exchanger. The combustion blower motor draws the hot combustion gases through that heat exchanger. These hot combustion gases are drawn by the combustion blower motor into a secondary heat exchanger. Here, latent heat is exchanged, lowering the flue stack temperatures and condensing the water vapor. The indoor blower forces circulated room air across the primary and secondary heat exchangers. Air picks up the latent heat of vaporization from the flue gases. The hot air created by the secondary heat exchanger is then circulated through the furnace duct system. The exhaust gases are very low in temperature and vented outside through a PVC pipe. The primary air for combustion is introduced from outdoors through PVC piping. There's also systems out there that are integrated mechanical systems. They do space heating and hot water. They are very high efficiency home heating systems that provide both of these. According to the combined annual efficiency, these systems are over 90% efficient. If you look on the one on the left, this is a hot water heater and the room air heating. The way this works is that the system produces 2 to 4 times more hot water than a conventional water heater. They are vented vertically or horizontally with a 2-inch PVC pipe. Outdoor air is used for combustion. The system contains 2 modules. One module is the heat module that acts as storage. Then you also have the air handling module that provides comfort conditioning for the home. On a call for heat, the pump in the air handling module draws hot water from the heat module or the hot water tank and circulates it. Heat from the water is transferred through the use of a heat exchanger and blower. The water returns to the heat exchanger module where it is reheated. The hot water for domestic use comes directly from the heat module. Two-stage furnaces are becoming more popular as well. They feature 2 levels of heating. It adjusts between high and low fire to meet demand. The majority of operation is in the first stage, or low heat. The low heat stage requires less energy and offers greater efficiency and greater cost effectiveness. On colder days, the furnace moves to a high heat second stage. The motor adjusts automatically to meet the changing needs. Two-stage heating reduces the temperature swings and provides constant and comfortable temperature. A variable speed indoor blower motor creates a more consistent airflow, allowing the air filter to trap more impurities, thus improving indoor air quality. The two-stage modulating furnace can provide rates between 40% and 100% of total capacity. A solid-state integrated furnace control initiates and manages the sequence of events. The unit automatically chooses the most efficient blower speed. There's also unit heaters that are powered by gas. They're used in commercial buildings and factories to heat certain rooms or spaces. They may be operated by natural gas or propane. A polished reflector radiates infrared energy that is converted to heat as it reaches the occupants and work surfaces. The surrounding air becomes warm by conduction and convection. Unit heaters are available for downward warm airflow. These provide high-velocity airflow around 2,500 feet per minute against large door openings. They are usually mounted 3 feet above and 4 feet away from the opening. The unit is operated by a door switch or a thermostat connected in parallel. We have to make sure we properly vent gas furnaces so that we get rid of all the exhaust fans. Areas critical to venting a furnace: you have to know the furnace capacity, the type of piping, airflow, the length of run, the heat load, the number of elbows, and manufacturer's recommendations, as well as local code requirements. The flow of chimney gases out of the flue and chimney affects the heating efficiency. There's a loss of about 4 to 15% through the chimney. The chimney or vent pipe should extend at least 2 feet above the highest part of the roof to prevent back pressures in the chimney or vent pipe under windy conditions. The combustion gas flow is affected by the pressure difference between combustion air entering the furnace and the combustion air leaving the flue or chimney. Pressures in the building, atmospheric pressure, and the temperature of combustion gases also affect the flow of combustion. Exhaust gases are removed from conventional furnaces through a vent system consisting of a flue pipe that is joined to the chimney and vented outside. Flue pipe temperatures can reach between 500 and 600 degrees. The efficiency of this furnace is reduced by 30 to 40% because it's heat exhausted out of the chimney. Common types of chimney used are the Class A, which is masonry type, or Class B, which is double wall metal type, as shown on the left. We can also use PVC for the higher efficiency furnaces, or we can use a metal liner inserted the entire length of the masonry chimney. To install a chimney liner system, you have to have a clear, unobstructed chimney. Any tar or creosote must be removed. Check the chimney for any loose or missing bricks. Make repairs as necessary to provide a safe internal and external condition. The chimney must provide at least ½ inch space between the liner and the masonry inner wall. The proper liner and diameter must be used to ensure good exhaust. You must check for proper venting following installation and startup. High-efficiency furnaces do not require a traditional chimney. Flue gases leave the furnace at 115 to 118 degrees. Exhaust gases are vented outside through a PVC pipe. Outdoor air is brought into the combustion chamber through a PVC pipe. A furnace can be vented horizontally or vertically. You must provide a way for the condensate to leave the chimney. When venting a furnace horizontally, manufacturer procedures must be followed. Vent pipe should follow the shortest route with the fewest elbows. Intake and exhaust exiting a sidewall must be as accurate as possible. A drain line is necessary for disposal of condensate. Furnaces must be individually vented and not combined with other appliances. PVC connections must be tight and must not leak. When you install a Class A and B venting, you can use a bimetal damper that can be installed in the flue outlet opening. It must be thermally operated and it requires no switches or motors. The damper may be also electronically operated and wired to open on a call for heat. It closes when the thermostat is satisfied. This is to prevent backdraft into the house. You can also have makeup air units. This helps solve negative pressure problems created by tightly constructed homes. It allows a slight pressure to build up inside the homes, which prevents infiltration around windows and doors and eliminates drafts. It's required by many local codes and regulations. By using a makeup air unit, you'll improve furnace efficiency by providing proper air for combustion. It delivers fresh air to the furnace. Air is then cleaned by the filters, heated or cooled as needed, and circulated through the duct system.